Hello everyone. In this session, we'll see the continuity of a function. So far we have seen the limits of a function. Now, we may use the same function graph we have used last time, but let's see. Let's say if there is a function f of x, then for f in the sense f of x to be continuous at x is equal to x naught, the conditions are, the first condition is that the limit of the function x tends to x naught should be existing. Secondly, the function must be defined at x is equal to x naught, and this limit of function for x tends to x naught should be equal to the function value at x is equal to x naught. You can also write it in this manner, that L should be equal to f of x naught, because this is the limit L for the x tends to infinity, and the function value at x naught is. In the case of limit, we said the function may or may not be defined at this interval or at that point x is equal to x naught. But for the continuity, it is must that the function should be defined at that point x is equal to x naught. The limit should exist at that point x is equal to x naught, and like we had in the previous case, I'll draw it here. Let's say this is x naught. So in previous case we said it may or may not be defined at this point x is equal to x naught. This is x, this is f of x. But now it should be defined, and the left limit and the right limit should also be coming to the same value L when we are approaching x is equal to x naught from either left hand side or right hand side, right? Now what if let's say the function f of x is defined for x greater than equal to x naught. What if this function f of x is defined for x greater than equal to x naught, or let's not take x naught, let's take some other value. Let's take, then now that this function is defined only for the value alpha or greater than that value, that we cannot check the values for function values for x less than alpha. In that case, at the end point, so we are talking about the end point. So in that case, what we need to do is we need to check the function for x tends to alpha plus, and it should be equal to f of, let's say, alpha. That means it needs to have a right hand limit same as the function value. So this alpha plus is the right hand limit, and this is the function value itself. So nothing to write about this, right? And what if the function is defined for, let's say, x less than equal to alpha? That means it is not defined for values greater than alpha. In that case, checking the, like we are checking at this, let me finish this. So in this case, we'll have to write or check the left hand limit x tends to alpha minus, and this should be equal to f of x. So this is the left hand limit, and this is the function value, right? So what we were talking about is that there is a certain endpoint for this function defined. There is, I mean, it is not defined after that point. In that case, checking at the endpoint, we are checking at the endpoint. So this endpoint is the left end, and this is the right end, right? If this is less defined for x less than equal to alpha, then this will be the alpha, and if it is, so it is, in this sense it is defined, and if it is greater than alpha, then it will be like this. This will be alpha, and in on the other side, on the right side, it will be defined, right? So in this case, for greater than equal to alpha, we are checking the right hand limit, and for less than equal to alpha, we are checking the left hand limit, right? So this is about the endpoints, and then we may be checking the continuity for an interval. So let's say continuity for an interval, let's say a to b. Then we'll have to check three things. First, function is continuous between a to b. You must be understanding that this is a closed interval. So closed interval includes a and b. This is like greater than equal to a and less than equal to b. So in this case, the function should be continuous between a and b, and for the left hand limit, you may check it that this value, the right hand limit of, that is at x is equal to a, will be checking function value x tends to a plus, and this should be equal to f of, let's say, a. And for the upper limit, we'll be checking the left hand limit. So f of x for x tends to a b minus, and the function value f of b. So if these three conditions are satisfied, we can say that function is continuous for this interval. Apart from this, we can check some of the properties of continuity. That is, if f of x and let's say g of x are continuous, let's say at x is equal to x naught, then f of x plus and minus g of x, c times of f of x into g of x, and f of x by g of x condition g of x naught is not equal to 0 and the c is a scalar. These all set are all continuous at x is equal to x naught, right? So whether it is sum or difference or a scalar multiplication or the product of two functions or division condition, the lower one is not 0 at that x equal to x naught, then we can say these all definitions or combinations are continuous at that point x is equal to x naught. Also, there is continuity of composition function. Continuity of composite function. So let's say there is a function f of x which is continuous at x is equal to b, and let's say there is another function g of x for which x tends to, this is b, so let's say a, so x tends to a gives b. That is, overall this g of x is continuous or defined, or it is having limit at a, right? Then the function of f of g of x for x tends to a will directly become f of b, right? In the sense that this function f of x is continuous at x equal to b, and this g of x limits to b for x tends to a, then the composite function f of g of x where x tends to a will directly be f of b. Why? Because f of x is continuous and g of x is limiting to b, right? Also, you can also write it in this manner, that the function f of x equal to, let's say, g of h of x, right? F of x is g of h of x, where g and h are like continuous. So let's say if h is continuous at x is equal to, let's say, a, and this g is also continuous at h a, then this function f is continuous at x is equal to a. We can do it in a fresh page which will make it more clear. If, let's say, f of x is g of h of x, right, where g and h are also some function, and h is continuous at x is equal to a some point, and g is continuous at h of a, then f is continuous at x is equal to a, right? So first of all, this f of x is g of h of x, so this is a composite function, and now h the function h is continuous at x is equal to a, and now that g of h of x, so g is continuous at h of a, then f becomes continuous at that point x equal to a. Why? Because this g of h of x, so g of h of x, so for g we have the variable h of x, we have the value h of x, and now g is continuous at h of x, where h is continuous at x, then f becomes continuous at x, right? So these are some of the requirements for the continuity, and we can check some questions on this.